Does anybody know what absolute value means? Go ahead. Yeah, how do we explain it? I mean, does anybody know how to simplify number two here? Go ahead, Vladimir. 8. It goes positive, right? Absolute value goes positive, but why? Can you explain it? It's kind of opposite. If it's negative, it's opposite. But there's another key word that will explain it. You have something? It's in those little lines. It's in the bars. Those are the absolute value bars. Good. Keep going, guys. Keep going. Do you have something? What does it even mean? Like, why is it opposite? Why did this go positive? What are the bars? What does it even mean? You have something, Neil? Okay. Anybody? It's talking about distance. Absolute value is distance. Go ahead. Yes, distance on number line. So when we think about -8, it's right here. -8. It's 8 units from 0. And that's why we go positive. Not because necessarily we memorize that it's the opposite, but because it's just how many units away is it? This is 8 units away. So we're talking about distance when we talk about absolute value. All right, number 3. So, you feel like, yes, absolute value, I get it. And then everything gets tricky. Number 3. It's shown within so many symbols here, I know. There's a negative sign and then the absolute value bars. Okay? What I wish it said, what it should be, if it was more clear, what it should be would be -1 times the absolute value of 13. But instead they just put the negative in front there. And then you start questioning things. But this is just -1 times absolute value. So the absolute value of 13 is 13. Distance is 13. The negative sign stays out front. Because it's out front. It's not inside. So this is -1 times 13. The answer to number 3 is actually -13. And that's because this negative sign is not in there. It's outside there. So you have to take a minute and let that sink in. And sometimes, especially if you're looking up here, it's not right in front of you, your eyes jumble that all up. Look at all the different lines up here. It's a lot to jumble up. Hopefully it's easier if it's on paper right in front of you. Let's see a thumbs up if you finished 4 and 5 already. Okay, that's probably everybody who's going through. I will continue. Here's number 4. Absolute value of -2 plus the absolute value of 2. I'm going to show my work and take it one step at a time. What's the absolute value of -2? Somebody in these 2 rows. 2. And what's the absolute value of positive 2? 2. So this answer is 4. Without the bars there, it would have been a hot 0. But here we got bars, 2 and 2 make 4. It's a hot 0. Okay, number 5. Okay, weird. Big bar, -5 times -4, big bar. There's a lot of people who could get this right, but they're getting it right on accident. What I want you to know, if possible, you do this work first. So, whatever's going on in there, do that work first. Because it's like PAM but PAM should really be GEN dogs. Have you ever heard of GEN dogs? What would the G be called instead of PAM dollars if you put a G in there? Grouping symbols. It's grouping symbols. It's not just parentheses. It's all grouping symbols. So these bars are considered grouping symbols. So first I'm going to do a negative times a negative is a positive. And this is the absolute value of positive 20, which is 20. Probably what I got. All right, so we'll transition into classwork. You can see this is our today. We're going to go from homework into classwork now. I'm going to have you open your book up. Yes, I believe it's been 10 minutes. 1:46. Yeah. Who just spoke? Did you ask me when you came in? Yes, you're second. You should just go. You're so close. No. You're third? Fourth? Fifth? Sixth? That's it for the day. We don't need to talk about it anymore. Alright, we're on page 43. We're doing A through D. And then we're going to do notes. And then we're going to do page 46. And then you get your assignment. Yep. No, right now you should be on page 43. That's what I had on the slide.
Yeah.
Who's got their book? Who's got page 23? Who came to class prepared? Let's see it. Let's see page 43, everybody. Ready, what is it? It's page 51 number. So, alright, this says, and I don't like it. Really, what I like, personally, is if the whole class stays totally silent and I do math all day and you just sit there and copy me. Because that makes my job really easy. But as it turns out, that's not what's best for you guys. You guys are to explore this a little bit on your own. You're supposed to have a moment to work with a partner. You're not just supposed to sit and copy me. So right now mine is blurry, but you should have this on page 43. You may talk to the people around you on task about letters A through C. Before I even tell you anything about it, I'm supposed to let you look at it, think, talk, and try to figure it out on your own. So go ahead, give a few minutes. I'm all the way over here. Is it in your face?
Can't compliment my homie. I know girls that do. I knew girls that do that. Yeah, they just want girls that they have guys. Bro, I cannot read that.
I know. Yeah. And I heard some people on task. That's great. That's good. As time went on, we started saying, so let's get back together and try to figure this out. Number one. Now, can anybody in fancy math words, or even just in your own words, try to explain what the equation means? Yeah, you want to try it? Okay, I love what he's saying. He's saying, you know what? You could probably just look at it logically. 1 plus 2 is 3. There's no negatives that you really have to think about. And that's good. That's half the answer. So good. Does anybody else? Yep, that's half. We're halfway there. How about these bars when it comes to the word distance? I already put up here the absolute value of distance. Can anybody try to explain this using the words distance? Distance. X plus 2 distance. That's a good try. I saw that count. Try. Another good one. The kid in the green coat, right? Yes. Okay. I love hearing you guys try to explain this in your words. Okay. I'm gonna go ahead with some fancy teacher talk and say there's lots of great ways to say this. I'm gonna say the distance is 3 units from 0 when x is added to 2. That's one way, but I mean, let's all say different ways. Now, you know, you already gave us an answer. X is 1. Let's see if if anybody else came up with x is 1. That's good. That's about half the class and that's half the answer. There is another right answer. What'd you guess? Negative 1. Negative 1. I love that you're thinking negative because it is negative. Okay. It's not negative 1, but it is negative. Jesus, thank you. So negative 1 plus 2 would be 1. So 1 doesn't work, but there is a negative number that works, which is crazy. Yes. Negative 5. How could negative 5 possibly work? Let's check it out. Nevaeh, Negative 5 plus 2 is negative 3. And negative 3, the bars will go positive. Let's check it out. Negative 5 plus 2 equals 3. Is this right? Is the absolute value of negative 3 3? Yes, it is. It works. Negative 5 plus 2 is negative 3. The bars make it go positive.
But I thought it was negative 1.
Let's check negative 1 so you can see it. I mean, you're getting the concept. It's negative 1 plus 2 is 3. Jesus, what's negative 1 plus 2?
1.
Yes, good. He's picturing it. And what's the absolute value of 1?
1.
1, not 3, right? So that one's not working. I'm going to put a line through it. But you were right to think negative. What does it is negative 5. What's negative 5 plus 2?
3.
Negative 3. Absolute value is 3. Okay. So this is crazy. This is two completely different answers. You just don't have to do C. So I'm going to write a statement down right now. I write it on this side of the board. Write this somewhere on that page. No, you don't. No, you don't. Absolute value equation can have how many solutions, you guys? What goes in the blank? 2. Absolute value equations can have 2 solutions. How annoying! I thought we were solving for 1, and now we get to do it twice.
Yay!
Absolute value can have 2 answers. That's kind of messed up. And let me show you an easier one to see, okay? What if it just looked like this? Absolute value, I'm going to put x in here, equals 5. Well, those are huge bars. When you look at this, you should question, what is x?
5.
X is 5. What else is x?
Negative 5.
Also negative 5.
So it's negative and 5.
So when they put a letter in there, and they don't tell you what it is, you have to think about both possibilities. That maybe that letter was a positive, or maybe, hypothetically, there was a negative in there, and the bars turned it positive. So you almost have to think back in time.
Oh, yeah.
Was there a negative in there, and the bars turned it positive? We don't know. We don't know. So we have to show both. Okay. All right, guys. So let me give you a few notes on that. A lot of these problems are going to become more difficult. So let's look at a few notes on that. That is so messy. Let me clean this up. So right here, let's write this. Go back to your Bower page. This is chapter 1.5. Solving absolute value equations. These are really shorted. They're really made short. I'm going to rewrite it more neatly. Shorted. So you can do this in your notebook under Bower. After the bars are isolated. So just like before the quiz, we started out with some basic equations, and then boom, there were parentheses, and boom, there was distribution, and then boom, there were fractions. Some of these equations are going to get pretty long. So this occurs after the bars are isolated. You're going to set up 2 problems. Because absolute value can show up on the negative side, or it can show up on that positive side when you don't know what it is. I'm rewriting all of this. For the first equation, You're going to drop the bars. You're going to keep the same. And solve it. But the second equation is going to be different. You're going to drop the bars. You're going to change the solution to negative. So you can figure out what is that hypothetical negative answer that the bars turn positive. When you're done writing it down, we're going to go to page 46 and try 4 of these together. So I'm going to stop and let you write it. So when you're ready, you go to page 46. So when I look here and I see this gray box open, I'll know you are ready. Are you already ready? Yep. If you don't have a chance to write this down because you're in no mood or whatever, there will be a video later. Our school is this is recording it right now. So you click on the video, don't watch the video. Fast forward it to what you need to see and pause it. Okay? You're going to page 46. You're trying 1 through 4. So I'm looking around to see what's ready. Just about there. Right now you're doing class art, page 46. 46. Let's try these 2 sets. Don't do that, King. All right. Let's see if I can. Oh my gosh. That won't be any fun. Okay. What's going on now? Here I am. All right, we're going to solve, and it says graph the solutions on the number line. Okay, so it says isolate the absolute value bars. That's done. And then it said set up 2 equations. Drop the bars, keep one the same, turn one negative. There's 2 possibilities. The first one is that x actually equals 10. There could be a 10 in there, right? The second one is that it could be negative 10. So you drop the bars and keep it, or you drop the bars and make that value negative. There's either a 10 in there or a negative 10. Now to graph on these number lines is kind of annoying. They don't have numbers here, so you get to number them how you want. You can go by 1s or 2s or 5s. What about 10? You could go by 10. I'm going to go by 5. I'm going to go 5, 10, 15, negative 5, negative 10, negative 15. I'm just going to put a dot at 10 and a dot at negative 10. That's it. That's it. Did you remember that bit? I don't know. You don't have to do it right, man. Don't Jesus, look at me.
Look.
Where's your book?
First one.
Jesus. Let's say.
Let's get there.
Skip that one. Write this one down on your paper. You try this one. Because you called out 10, negative 10 pretty quick. All right? Let's try this one. It's a little harder.
One got to be like -5.
Yes. So good. That's spatial reasoning. It's good.
Minus 4 or negative 1? X like times negative 1?
X minus 1.
X minus 1 equals 4. It's a 5.
5.
5 minus 1 is 4.
What's the other one?
So it's 8. So it's on 4 on 4. So it's 8 apart.
Yeah.
Yeah. Is that right?
Yeah. So what's the other answer now?
The other answer. Negative 8?
No.
No.
It's 8 apart. Your first answer is at 5. Where's your second answer?
That's
No, you just said that so well. The other one would be negative 3 if they're 8 apart, right? If you're at 5 and you count 8, don't you land at negative 3?
Yes.
Yeah. Yeah. What? I don't know how you came up with 8 apart. So if you can come up with 8 apart, just use the number line. This was 5. And count 8 the other way, and you'll have your other answer.
9.
One answer is 5. What's the other answer though? 5 minus 1 is 4, but we need 2.
-5.
No, I don't think it's that. I wish it was that. I'm gonna have to use a process to come up with it. You gotta make 2 problems. Okay? So the first one, you just drop the bars. And you keep it the same. So it's x minus 1 equals 4. Solve that guy. The second one's a harder one. The second one, you drop the bars and you make the answer negative. So it will be x minus 1 equals negative 4, and you solve that. That's the process you have to know and remember. So this one, I add 1 to both sides, and I get that 5. 5 works, and you can plug it in and check it. And you get the absolute value of 4 equals 4. And now this one, this is the one I couldn't really think of on my own. I have to use a process. Add 1, and what's this one? Negative 3. Negative 4 plus 1 is negative 3. You know I can check it because I question that. I'm like, how does negative 3 even come into play here? Negative 3 minus 1 equals 4. And then, so that's the absolute value of negative 4 equals 4. Oh yeah, so absolute value would make that positive 4 does equal 4. So negative 3 works, and so does 5. And Neil came up with that they should be 8 units apart, and those are 8 units apart. He said he doubled the 4 and got 8. I don't know. But he came up with that a whole different way. It's really cool. Yeah, so he said
negative 10 is
20 apart. Okay, I'm with you there. 10 and negative 10 are 20 apart. And then for negative 4 are 8 apart. And then you come up with the first one. You count 8 that way, and that'll tell you the second one. That's like a cheat code. So that's -1, that's -2, and that's -3. So I'm plotting my answers at 5 and at -3, and they're 8 units apart. You follow that? It's kind of neat. It's kind of neat. You follow it, don't you? The 8 apart? Or do you like the process?
I don't like neither.
Pick one.
Neither.
Pick one.
Either
Okay, should we go to the next one? Alright, number 3 is a trick. This one's a mean trick. They're playing tricks on us.
Who's next to the rest one?
I don't know. I did my job. You're next? I already caught out like 6 people. Did all 6 people go?
Yeah.
And he was the last person? Okay, and now you guys? Was she had her hand up? Riley had her hand up. Riley, do you know why this is a trick?
Because it's a fraction.
It's not the fraction.
The negative.
It's the negative.
Yeah.
Okay, look. That's a positive 10. That's a positive 4. What? Is it absolute value if the bars are there? Isn't it supposed to be positive? Absolute value is supposed to be positive. So if it's presented to you set to a negative like this, there's nothing I could plug in for x that would after the bars be negative. So this is no solution. The answer
Cannot be solved.
cannot show a negative when presented. I don't know. Riley had her hand up exactly when you asked, can you go? So
Brought the reduced shoe.
I think neither one of you will. Just sitting in your mouth. So we're gonna call this one new solution. If the bars are there and it shows you put the negative, it's no solution. So number 4, how do we know that it has no solution? Yeah. With bars present, equation must be positive. So whenever we make it positive, or whenever we make it negative, we have to drop the bars first. Notice I wrote drop the bars. We drop the bars and go negative. There, it's presented with bars and negatives, so that's no solution. Okay. That's it for classwork. That's it for notes. You guys are on assignment up until dismissal, which is page 51, number 1 through 14. One of you has time to go. Who's it gonna be? Is you or Riley? Riley, you wanna get your work done? So what? You good just staying to get your work done? You good? Alright, I'll put the problems here so you can do them on your paper, okay?
No, I have it.
Okay.
I just didn't have one page. I had the rest of it. I just lost that one page at home.
I need to tell you something about this. Do you have a question? To extend, let me look real quick at tomorrow first. I do have something for early.